For centuries, the formula for global power was brutally simple: control the seas, command the largest armies, possess the most devastating weapons. Power was measured in aircraft carriers, nuclear warheads, and the economic might of nations. But this formula is now obsolete. A new, undeclared world war is already being fought. It's a conflict waged not with soldiers, but with geologists, not with tanks, but with mining contracts. Not on traditional battlefields, but in the sterile clean rooms of semiconductor plants and the dusty open-pit mines of remote continents. This is a war of access. And the ultimate prize is a small, obscure family of 17 elements on the periodic table, the rare earths. The public remains almost entirely unaware of this conflict, yet its front lines are everywhere. The Pentagon sees it as the single greatest threat to American military superiority. Beijing sees it as the ultimate leverage to rewrite the global order. And corporate giants like Tesla and Apple understand it as a ticking time bomb under their multi-trillion-dollar empires. What do they know that you don't? They've read the data. They've seen the same alarming intelligence that we have, buried in the dense technical pages of reports from the U.S. Geological Survey and the International Energy Agency. And the data is unequivocal. Our analysis of these documents reveals two terrifying truths. First, over 85% of the global processing capacity for these lifeblood elements is controlled by a single nation, China. It is the most dominant resource monopoly in human history, far exceeding OPEC's control over oil in its heyday. Second, the demand for these materials, driven by the global transition to green energy and advanced AI, is set to increase by over 500% within the next 2 decades. This isn't a simple supply and demand problem. It's the blueprint for a global crisis. Our forecast models, based on these colliding trend lines of monopolized supply and explosive demand, don't just suggest a future conflict. They pinpoint a year of critical failure, a moment when the system breaks. That year is 2042. By then, the silent, undeclared resource war of today will have escalated into a full-blown economic and technological Cold War, fundamentally reshaping the world we live in. The device in your hands is no longer just a tool for communication. It is a piece of contested territory, and the battle for what's inside it will define the 21st century. So, how did we get here? How did we build a 21st century global economy on a foundation controlled by a single geopolitical rival? It didn't happen by accident. It happened through decades of strategic industrial planning on one side and short-sighted economic negligence on the other. To understand the sheer scale of this dependence, we have to look past the headlines and into the hard data, the kind of numbers that fill the dry, factual pages of the U.S. Geological Survey's annual mineral reports. And when you do, the numbers are staggering. The USGS data makes a crucial distinction that most people miss: the difference between mining the raw ore and processing it into high-purity, usable metals. While China currently mines around 70% of the world's rare earth ore, their true power lies in the next step. They control nearly 90% of the world's rare earth processing and refining capacity. This is the critical choke point. It doesn't matter if the United States, Australia, or Vietnam dig the rock out of the ground if they ultimately have to ship that raw concentrate to China to be separated into the individual elements that companies like Apple or Tesla actually need. For decades, that was the reality. Take the case of MP Materials, America's flagship rare earth mine in Mountain Pass, California. For years after its revival, it was a mine without a country, forced to ship over 50,000 metric tons of its raw concentrate to China annually, simply because the domestic capacity to refine it didn't exist. Think about that. The most strategic resource in modern technology, mined in the US, was entirely dependent on a strategic competitor for its value. According to the USGS, for 14 of the 17 rare earth elements, the United States' net import reliance is over 75%. For critical elements like yttrium and scandium, it's 100%. This isn't a vulnerability. It's a strategic headlock. But this isn't just an American problem. The European Union, with its ambitious Green Deal, is in an even more precarious position. The EU has virtually zero domestic mining or processing capacity, making it almost completely dependent on China for the very materials it needs to achieve its climate goals. This is the precarious situation on the supply side. a carefully constructed, near-total monopoly over the most critical industrial ingredients on Earth. Now let's look at the other side of the equation, the force that's turning this economic vulnerability into an impending global crisis, the demand tsunami. The International Energy Agency, the IEA, has been tracking this for years. Their reports are no longer just forecasting, they are sounding a global alarm. In their definitive report, The Role of Critical Minerals in Clean Energy Transitions, the IEA lays out a future where the demand for these materials simply explodes. It's a demand curve going vertical. Take the engine of the green revolution, the electric vehicle. A company like Tesla doesn't just build cars, it builds sophisticated electric motors powered by high-strength permanent magnets. These magnets are the most efficient way to turn electricity into motion, and their power comes from a specific blend of rare earths, primarily neodymium and praseodymium. According to the IEA, a typical EV requires over a kilogram of these magnet materials. Now, multiply that by the 100 million EVs projected to be on the road by 2030. The demand from the auto sector alone is set to increase sevenfold. Then there are wind turbines. The giant, direct-drive offshore turbines that are central to the EU's and America's clean energy strategy can contain over 600 kilograms of rare earth magnets for every megawatt of power they generate. To meet stated climate goals, the world will need to install tens of thousands of these turbines. The IEA projects that demand from the wind power sector will triple or quadruple in the coming decade. When you combine this with the insatiable appetite from consumer electronics, the tiny, powerful magnets in every iPhone, every laptop, every speaker, every drone, and the growing demand from robotics and automation, the picture becomes terrifyingly clear. We are entering an era of unprecedented global demand for a resource that is almost entirely controlled by a single power. This brings us to the final and most dangerous piece of the puzzle, the national security equation. This is where the dry data of the USGS and IEA transforms into the high-stakes strategy debated inside the Pentagon. As the Center for Strategic and International Studies, or CSIS, has repeatedly warned, America's military and defense industrial base is critically dependent on Chinese rare earth exports. The F-35 Lightning II fighter jet, the cornerstone of American air power, requires approximately 427 kilograms of rare earths. They are essential for its advanced sensors, its radar-absorbent coating, and its electronic warfare systems. The guidance systems of Tomahawk cruise missiles, the sonar arrays of Virginia-class submarines, the targeting lasers for advanced munitions, all are fundamentally reliant on these 17 elements. And strategists at the Pentagon know this is not a theoretical vulnerability. They have a terrifying precedent. In 2010, following a maritime dispute, China abruptly cut off all rare earth exports to Japan, a move that sent shockwaves through Japanese industry and demonstrated to the world that Beijing is not only capable, but also willing to weaponize its control over the supply chain. This event was a wake-up call. It's the reason why the US government has started pouring millions into companies like MP Materials to help them build their own domestic processing facilities. It's why the US is strengthening alliances with partners like Australia, home to Lynas Rare Earths, the largest non-Chinese rare earth producer in the world. This isn't about trade deficits or economic competition anymore. As CSIS makes clear, ensuring a secure and resilient supply of rare earth elements is now a fundamental imperative of national security. So this is the reality on the ground, a near-total monopoly on supply, colliding with an exponential, non-negotiable wave of demand, creating a critical dependency that now threatens the military and economic security of the United States and its allies. The stage is set. The pieces are in place. The only question is what happens when the system finally breaks. What happens when a global system, stretched taut by the forces we've just described, finally begins to break? Our analysis indicates it won't be a single cataclysmic event. It will be a cascade of fractures, a slow, grinding separation of the interconnected world we know today, accelerating through the 2030s and culminating in the critical flashpoint year of 2042. This future isn't science fiction. It is the logical endpoint of the trend lines that are already in motion. To understand it, we must forecast how this conflict will unfold on three primary fronts: the geopolitical, the economic and the technological. First, the geopolitical front. This is where the opening shots of the resource war will be fired, not with missiles, but with export permits and policy announcements. Our forecast model, based on historical precedent like the 2010 Japan embargo, points to a high probability of a major supply chain crisis in the mid-2030s. Imagine the scenario: a period of heightened tension, perhaps a dispute in the South China Sea or a political crisis over Taiwan. In previous eras, this would have involved naval deployments and diplomatic threats. But in this new era, China possesses a far more surgical and devastating weapon. They don't need a blockade. They simply announce what they will call a strategic resource export review. Citing environmental concerns and domestic needs, Beijing will declare a temporary but indefinite halt on the export of processed neodymium, dysprosium, and terbium, the holy trinity of high-performance magnets and advanced electronics. The act itself will be disguised in layers of bureaucratic ambiguity, but its message will be brutally clear. It is the weaponization of the supply chain, executed with plausible deniability. The immediate effect will be global panic. In Washington, the Pentagon will issue an unprecedented alert, stating that military readiness is now directly threatened. Production lines for the F-35 and Tomahawk missiles, which depend on a constant flow of these materials, would face the prospect of a complete shutdown. In Brussels, the leadership of the European Union will convene emergency summits, realizing that their entire Green Deal, the cornerstone of their economic and environmental policy, is now hostage to a foreign power. In the boardrooms of corporations like Apple and Tesla, the response will be sheer terror as their multi-billion-dollar quarterly projections evaporate overnight. This single act of economic statecraft will achieve what no army could. It will hold the entire advanced economy of the West hostage without firing a single shot. The inevitable response will be the formalization of a new global alliance. We forecast the creation of what will be called the Critical Materials Alliance, a strategic pact between the United States, the European Union, Australia, Japan, South Korea, and other democratic nations. This will not be a trade agreement. It will be a defense pact for collective resource security. Its founding principle will be that an attack on the supply chain of one member is an attack on all. This alliance will become the central geopolitical counterweight to China's resource monopoly, and the world will be formally divided into two competing blocs, defined not by ideology, but by their access to the fundamental building blocks of technology. This leads us directly to the second front, the economic war. With the geopolitical lines drawn, the free market for strategic materials will officially die. The Critical Materials Alliance will be forced to pursue a strategy of total supply chain independence at any cost. This will trigger a wave of state-backed industrial policy on a scale not seen since the Cold War. Forget small subsidies and tax incentives. We are forecasting direct, massive government investment, trillions of dollars, poured into companies that are now deemed critical to national security. In the United States, MP Materials will transform from a single mine operation into a national champion, tasked with building a vertically integrated mine-to-magnet supply chain entirely on American soil. In Australia, Lynas Rare Earths will see its operations underwritten by a consortium of allied governments, expanding its mines and building new, sophisticated processing plants in Texas and other friendly territories. This will be the Manhattan Project of the 21st century, a desperate, all-out effort to replicate in a decade what China spent 40 years perfecting. But this independence will come at a staggering price. Firstly, the financial cost. A Tesla built with magnets sourced and manufactured entirely within the alliance will be significantly more expensive. The price of an iPhone, a laptop, or any piece of advanced technology will climb sharply as companies can no longer rely on the hyper-efficient, state-subsidized Chinese supply chain. This will introduce new social and economic tensions, a greenflation, that politicians will struggle to explain to their citizens. Secondly, there is the environmental and ethical cost. Rare earth refining is a notoriously dirty business, creating significant toxic waste. China's dominance was built, in part, on its willingness to accept environmental degradation that Western nations were not. The uncomfortable question for the alliance will be, in a race for survival, do we compromise our own environmental standards to speed up production? Do we fast-track new mines in sensitive areas? This internal conflict, pitting climate goals against security imperatives, will be a defining struggle of the late 2030s. The economic war will create a brutal new landscape of corporate winners and losers. Companies that remain dependent on the old global model will face collapse. Those that adapt, that reshore their manufacturing and invest in the new, secure, but vastly more expensive supply chains will become the industrial titans of the new era. Finally, we arrive at the third and most consequential front, the technological war. As the physical materials become contested, the battle will shift to the intellectual plane, the desperate, high-stakes race for substitutes. With rare earth magnets and other components becoming either unavailable or prohibitively expensive, the central mission of every Western research lab, from DARPA to MIT, will be to design them out of existence. The goal will be to invent our way out of the crisis. This research will yield results, but it will come with a critical trade-off: performance. The first generation of rare earth-free electric motors, for example, may be heavier, less efficient, and offer a shorter range. The first rare earth-free LEDs for screens might not have the same vibrant colors or energy efficiency. This is the seed of what we call the Great Technological Divergence. Chinese technology, still having access to the highest grade materials, will continue along a path of peak performance and miniaturization. The technology of the Critical Materials Alliance, however, will evolve along a different branch of the evolutionary tree, prioritizing resilience, repairability, and resource independence over raw power. By the time we reach the 2042 flashpoint, this divergence will be complete. The world will no longer have a single global technological standard. Instead, there will be two distinct and likely incompatible tech ecosystems. An EV purchased in the EU might have a completely different battery and motor architecture from one sold in China. Software and components designed for one ecosystem won't work in the other. Your device will no longer be a neutral object. It will be a passport. Its internal components, its performance limitations, and its price will tell a story about which side of the new global divide you live on. This technological schism will be the ultimate outcome of the resource war, a world fractured not just by borders and politics, but by the very physics and chemistry that power our lives. The dream of a single, interconnected digital world will be over, replaced by a new reality of technological non-proliferation. The war for 17 elements will have resulted in two separate worlds. So this is the future that the data projects, a world fractured by the very elements that once promised to connect us. The scenario for 2042 isn't a Hollywood blockbuster filled with explosions and dramatic battles. It's a quiet, systemic reality. A new kind of Cold War, fought not over political ideologies like capitalism versus communism, but over access to the periodic table. It's a conflict waged in the silent hum of supercomputers, calculating new material structures, in the roar of earth movers creating new domestic mines, and in the tense negotiations of diplomats carving up the world into secure sourcing blocs. What we are forecasting is the end of an era. For the last half-century, the power of a nation was calculated using a familiar formula: the size of its economy, the strength of its military, the reach of its cultural influence. By 2042, our analysis shows that a new dominant variable will be added to this equation: material sovereignty. A nation's true power, its ability to act independently on the world stage, will be measured by its direct control over the supply chains for the foundational materials of technology. This fundamentally rewrites the rules of globalization as we have known it. The 20th century dream of a frictionless, borderless global market, where goods and components flow to wherever they can be made most efficiently, will be looked back upon as a brief, naive historical anomaly. That world is already dying. It will be replaced by the harsh, pragmatic reality of secure trade. Supply chains will be ruthlessly redrawn, pulled back from geopolitical rivals, and reshored along the lines of strategic alliances. They will become shorter, more redundant, more resilient, and fiercely protected. The primary question for any critical product will no longer be, how much does it cost? But where did it come from, and can we trust the source tomorrow? This shift represents a painful reevaluation of our global priorities. We have spent 50 years building a civilization optimized for one thing: efficiency. The next 20 will be a brutal, chaotic scramble to re-optimize for something else entirely: resilience. And the economic and social whiplash from that transition will be severe. It will redefine the very meaning of progress. So where does this leave you, the individual, in this new global equation? This geopolitical struggle won't just be something you read about in the news. It will manifest in subtle, frustrating, and deeply personal ways. It will be the nagging incompatibility between your alliance-made car and a charging station built on the rival tech standard. It will be the constant, mandatory software patches on your phone, not to add new features, but to maintain a fragile digital bridge between two diverging technological worlds. It might even be a sovereignty score displayed next to the price of a product, a government-mandated label telling you what percentage of that device was sourced, processed, and built within the secure borders of your geopolitical bloc. The freedom and seamless interoperability we take for granted will become a luxury of the past. The very device you use will become a daily reminder of the invisible walls being built around you. This forecast raises profound, unsettling questions that data alone cannot answer. What is the ultimate price of our technological ambition? In our relentless pursuit of faster, smaller, and more powerful devices, did we inadvertently build a global system so complex that it became inherently fragile? Did the sleek, glowing screens of our digital world blind us to our primitive, absolute dependence on the dirt and rock of the physical one? Our purpose here is not to provide solutions. It is to present a clear-eyed warning. The trajectory toward this fractured, contentious future of 2042 is not inevitable, but it is the path of least resistance. The choices that divert us from it must be made consciously, deliberately, and they must be made now. The forces are in motion, and the clock is ticking. This leaves you with a choice, not a hypothetical one, but the very real trade-off that will define the consumer landscape of the future. So we ask you, in the world of 2042, where every device is a statement of allegiance, would you choose a high-performance device tied to a fragile, authoritarian supply chain, or a less powerful, more expensive one that guarantees independence? Comment performance or independence below and tell us why. This is a prophecy from AI. Be prepared.